Hey, I'm starting.
Dad, can I talk in the chat?
Yeah, just don't say anything rude, okay?
Okay.
All right, welcome to the third episode of Thank God It's Kubernetes, TGI Kubernetes. This is where I have a beer on a Friday afternoon, play with Kubernetes and talk. My beer is overflowing. I would love if you folks have feedback or questions or ideas or topics. Just go ahead and let me know. And I really want this to be as interactive as possible. I think that's one of the things that's going to make it a lot of fun for everybody. So first off, if you can hear me, if you can see me, let me know, and in the chat. And so let's go ahead and get started. So this time, I'm not going to be talking about Kubernetes as much as I'm going to actually be looking at and talking about Istio. And I want to give a little bit of a warning here. I've never actually run the Istio bits myself. Now that means that we're going to be learning this stuff together. Hopefully, we'll have. Let's see. Yeah. Okay. Cool. Everybody can see in here. Hopefully, we'll learn some fun stuff, and I believe the team here at Heptio is taking bets on whether I'll actually get Istio up and running, and I'm fairly confident that we'll actually get there. So now a little bit of history. Istio is not all new. It's built on a bunch of ideas and concepts that have really been in production and used in a bunch of different ways. And so, if you compare sort of me coming at this with a lot of other folks who have, maybe looking at Istio for the first time, I think it's important to recognize that there's a lot of sort of concepts and assumptions that I'm already a little bit familiar with from previous experience that it might be new to folks. So if I make some leaps as I'm doing this and there's some stuff that you don't understand, ask and I'll do my best to answer, or we can go ahead and search Google ourselves and actually see what we end up with. Now, so the whole idea, my understanding of Istio is the idea here is that you have services running in a sort of microservices architecture and you want those things to talk to each other. I have a presentation that I've been doing probably for about a year now where I talk about sort of different levels of services and what they mean. And, and I can actually bring that up real quick. Let me see if I can find that. Yeah, let me go ahead and find it. So this is a talk that I give pretty often called the operations dividend. And so there's a lot of stuff that I like to talk about here, but one of these is here we go. Okay, yeah. Different types of services. So the idea is that like a lot of times you take a monolith and you break it out and you end up with a service as an implementation detail. And so this is a way where you take something that might have been a library before, might be some sort of convention, might be a team that's working as part of a code base, and you break that out over the network. The next thing that you end up with, and is that you end up with something like, say, MySQL Server, where you have one team that builds it, and everybody actually builds their own private version of this thing. Databases are a great example of this, but there's other examples, at least that I can think of, in terms of my experience at Google, in terms of where we see this pattern. And so that shared artifact, that proven shipped packaged piece of software might actually be something that you buy from somebody else or that another team in your company makes. And then the next level here is a shared instance. And this is where I think where things start to really get interesting, where you actually have a single service that gets used by a bunch of teams within your organization. And it really starts to have outsized impact in terms of as one team builds something, it can be used in a bunch of different places. And And then the final thing here is this is what most people think when they think about web service that I'm buying from another company. Like if you use AWS, I call that a big S, capital S service, right? You're essentially, using a web service, but there's all sorts of block and tackle and problems that you have to deal with when you're talking about offering a service to the public versus offering a service to another team inside of your organization. And if we back up to number 3 here, this shared instance, and as that starts to permeate the culture of how a business does stuff, and folks are proud of the fact that they're building some value that they can then deliver to other parts of their organization, the end result here, and I was calling this a service network, right? You end up with if you look at your production infrastructure, there's no clean cut to say this is this app and this is that app. The app ends up being a front end, but that app ends up being built on the backs of all sorts of other interesting services behind it. And so this is a thing that I saw work really well at Google, and I know that there's other companies that have had success with this. And a lot of times when folks say microservice architecture, this is one of those things that they have in their mind, is that it's not good just for one team to start doing this stuff, but it's also something that starts to really impact how a large organization can act. And so the problem here is that there's a lot of problems. There's a lot of block and tackle and plumbing that needs to be done as you start moving to the service network. And it really is sort of splitting the difference between something that's internal facing and you can take some shortcuts versus something that has to be offered to the rest of the world. And you have to make sure that you really lock it down. You really get it right. You don't have any issues with noisy neighbors, that type of thing. And so this is really where Istio comes in, I believe, is that it actually helps do a lot of the work behind the scenes to make these service networks, or as folks are calling them now, service mesh, work. And so the specific things that we're talking about here are a bunch of good things in terms of making sure that if a service is overloaded, you don't continue to overload it, making sure that you can find where those services are and be flexible and decoupled in terms of being able to name and move and rename these things. And then things like security, right? So you want, when we think about like a service calling another service, a really critical thing here is that, you want to make sure that nobody else can impersonate or eavesdrop or what have you. So you want to be, you want to keep track. Sorry, I'm looking at the chat here. Some folks are asking about some PRs that are a little bit old there. I can talk about those for a little bit, maybe towards the end if we have some time. So I'll try and get to that, James. But if not, that's the type of thing that we can definitely tackle in a future issue, future episode. So you want these things to be able to talk to each other. You want to make sure that you can't impersonate stuff. But really, in some ways, that's a little bit of a secondary type of thing. Because, you might have bad actors in your company. You might have intruders that are sniffing network traffic. And it's good to protect against that. But the biggest thing you want to know is actually who's calling so that you can actually start implementing some smart ways to deal with this very sort of multi-party type of service mesh. And so one of the big things that Istio brings along is security and identity about who's calling which service. And that's a really important part of the story. So hopefully that sets things up a little bit in terms of the problem that Istio is solving. Now, one last thing. The pattern here for solving this stuff and actually taking all the knowledge of how to operate in a service mesh, generally that's been extracted into a library that then gets linked into the program. And this works in big companies that are relatively homogeneous in terms of the languages and the environments that they're writing. And I think the two big examples here are Google. Google generally in production, when I was there, had 3 languages that they use, C++, Python, and Java. Go is definitely an up and coming there now. And I think the other example here is Twitter. And they've open sourced the sort of service mesh library that they have. It's this thing called Finagle. There's a startup, Buoyant, that created an open source project around Finagle, essentially taking that and turning it into a standalone service. That's what Linkerd is. And so it's taking the knowledge that's been built up in the case of Linkerd, the code that was delivered as a library in the past, and then packaging that as a separable binary that you can use. Now, Google in the past had libraries, and in fact, Google had a library per language, right? So there was a Java library for doing all that stuff. There was a C++ library, and then the Python stuff using Swig pulled in the C++ stuff. And I think one of the problems that we've seen, and I don't know if Twitter's hit this, but I know it's definitely something that Google has hit, is that as we start looking at more and more languages, and as we want to be able to rev the version of this infrastructure without revving the application, we want to decouple these things. And so the model that's actually being sort of evolving out of this is this idea of sidecars, where you run your application, and then next to your application, you run something that implements all the magic that makes the service mesh work. And in the case of Istio today, that sidecar that's actually doing that magic is this load balancer from Lyft called Envoy. And in the case of sort of the Linkerd world, they took the Finagle library, extracted that into its own binary, and are moving that forward as an independent entity called Linkerd. Linkerd is now part of the CNCF. I would not be surprised if at some point, something like Envoy or Istio in general end up being part of the CNCF. Now, but okay, so if the thing that's sitting next to your binary is Linkerd or Envoy, what is Istio? Well, Istio is essentially the stuff that brings all this stuff together, so that instead of worrying about configuring and programming individual proxies in a bunch of different places, it actually helps you to sort of put the whole thing together in a way that really makes a lot of sense. And one of the interesting things that was announced, I think last week, is that the Linkerd folks, the Buoyant folks who are in the driver's seat mostly for Linkerd, are looking to integrate that with Istio. So it's not really an either or with some of these things, but really finding the right technology that makes sense for you. Okay, so that's 10 minutes of me yapping. Hopefully that sets up the context of sort of why this stuff is so interesting. Let's just go ahead and now start driving in to Istio. Just first of all, my setup, I went through and I started a cluster using the Heptio Kubernetes quick start. If you just Google for that, here you go. And so this is a CloudFormation template that brings up a cluster. I have one of those up and running right now. And if I go through here, I can do cube, let's do I have k get node. So, alias k equals cube control, k get nodes. So you can see I brought up a cluster with 4 nodes and a master. I don't know how many I'm going to need, but hopefully that's big enough to actually start playing with Istio. And, oh man, I got a puddle of beer. I foamed up. It's all over the counter. Got to keep things clear. It's not the first time I spilled beer during one of these. All right. Okay, so there we go. Let's go ahead and get started with Istio. I went to the Istio homepage, istio.io. Now, this is an open source project mainly being driven by Google with some other folks involved. I know that IBM has been doing some interesting stuff here. Red Hat has been involved in some ways. And so this talks about sort of what's the things that you can do with Istio, hit some of the high points that I managed, intelligent routing and load balancing. So this is who can find what, when, where, and when. The fact that it works across languages and platforms because it's not a library, it's actually a sidecar. And then fleet-wide policy enforcement. So this is the idea. Instead of configuring this stuff at a local level, you're actually doing it across a fleet, across a whole bunch of machines. In-depth telemetry and reporting. Oh, that's something I missed. One of the interesting things that I thought was great about Google is that as we got more and more commonality about how we did this service mesh stuff, you could actually start writing dashboards and systems and debugging that really cut across all of this stuff. And so want to learn more? Yes, let's get started here. Concepts, tasks, samples, downloading and installing. Let's just skip straight to that. Okay, so here they're go ahead and get a Kubernetes cluster. I already have one. They're telling me to use GCE or Bluemix. So you can tell who's sponsoring any piece of content by the instructions for getting a Kubernetes cluster up and running. That's why I'm using the trademark, no, it's not trademark, but Heptio Kubernetes, Kubernetes Quick Start by Heptio for AWS. I think that's what we ended up calling the darn thing. All right, so for the pre 0.2 release, Istio must be installed in the same Kubernetes namespace as the applications. Okay, so that's interesting. Instructions below will deploy Istio into the default namespace. They can be modified for deployment into a custom namespace. Okay, so quick refresher for folks who are not super familiar with Kubernetes. Namespace is a concept in Kubernetes that really is a per team thing. So the idea is that namespace A and namespace B and namespace C can be assigned to team A, team B, and team C. If I bring up foo in namespace A and foo in namespace B, those things actually are different. And we use namespaces a lot as a way to most of all, keep two sets of folks from stepping on each other's toes. But it also ends up being a lot of times a convenient way to attach sort of quota and other sort of policy, security policy of who can change what, when, and where. Okay, so let's go through, and I'm going to actually look at this because I don't pipe stuff to bash without looking at it. So this thing, okay, so we have a version in here. It says, are we doing Darwin or Linux? Oh, look, we're doing old school comparisons here because it's using shell instead of. I go through and I download this thing. I untar it. And then it says, add that to your path. So it looks like all this thing is doing is untarring a tarball, detecting my OS and untarring a tarball. So let's go ahead and run that. So yeah, if I wasn't doing this live, I probably would have already looked at that and said, don't worry, it's safe. But okay, so let's go ahead and do that. So it's curling this thing down. How fast is our internet here? Oh, not too bad. I was grabbing it from GitHub though. Okay, so it might be. Okay, and then we'll go through and we'll add this to our path for the purposes of the TGIK stuff. So let's look at what's in there. So there's a whole bunch of stuff here. So they create a tarball. Contributing license. Is this install bin? Is this just a capture of, no, this isn't the code. So there, okay, so there's samples and stuff. Okay, so it looks like what we have is we have a binary here, which is Istio control. Look at that, okay. That does a bunch of stuff. So we'll figure out, play with that at some point. There's an install here. Is this, oh, that's a directory. Okay, well, let's just go through the steps here. But okay, so extract the installation file. Well, that's what it does. And change directory location when files were extracted. Following instructions. Okay, so we have YAML installation files for Kubernetes, sample apps, Istio control client binary, and the istio.version configuration file. Add that to the path. We've gone ahead and done that. Okay, so actually what I'm going to do is I'm going to bring up a VS Code instance here so that we can actually look at stuff before we run it. So I'm not catting stuff all over the place. Okay, so all sorts of stuff here. Istio.version. Okay. Okay, so this is interesting. So this is, this will pull in all the artifacts for downloading stuff, where the different images are that they're using. They got thrown up on the Docker Hub. Okay. Okay, so it says run the following command and determine if the cluster has RBAC enabled. We do, of course, because why wouldn't you? If the command below displays an error, it does not display anything, it means the cluster does not support RBAC, and you can proceed to step 5. Otherwise, we need to do some RBAC stuff. Install Kubernetes Istio RBAC beta. Okay, let's go look at that file. Istio RBAC beta. All right. So folks were saying that shadow makes you a little dizzy. That's what Matea said. Is this like, is there a shadow behind me? Like, oh no? Or is it, what shadow? See if I can fix it if it's something on the screen here. All right, so go ahead and look at that. Okay, so we have a cluster role that says the API, okay, so that you can do anything with the istio.io third-party resources, extensions, and ingresses. Okay. So this is a little bit bigger than it needs probably, because you need one, at least for the third-party resources and extensions. That should be a one-time setup type of thing. Oh, from the Istio page, the shadow. Let's see. There's me. Oh, the shadow. Oh, look at that. The shadow on the... That's fancy. Look at that. Somebody read a JavaScript tutorial. Okay. All right. So this thing... Okay, so let me... I was going to do a session on... let's see. So Eli's asking, is there a way to enforce that everything proxies through Istio? Couldn't pods still connect directly to services? That's a really good point. I think that's something that we can talk about. I think there's two parts of it, is that can we actually prevent pods from exposing anything except through Istio? And some of this is the workloads themselves can actually only listen on local hosts. So it's like, what port do you bind on, and let Istio do everything else? I think we need to get some diagrams and sort of bring everybody else along. And then there's the question of, as you submit jobs to Kubernetes, is there a way to enforce other policy around who can do when, what, and where? And that's an evolving story. And I do know that there are some features that are being discussed now for Kubernetes. Whether these things make it into 1.8 or 1.9 or beyond, I think is still a little bit up in the air. All right, so here's what we're doing. We're going through, we have the API groups. This thing then can actually go through and says that this is a cluster role. Okay, so this is probably a little bit wider than it needs to be for Istio. Because it can go through and actually modify any pod on the system. And my guess is that it only needs to be able to list and read these things. And every config map across the system and services, it can do everything with it. So I think it's worthwhile. Hey, Istio team, if you're watching this, we can go ahead and lock this down a little bit. Okay, but they do have some more lockdown roles here for the Istio CA. Okay, it can actually go through and look at secrets across the entire thing. So that means that the Istio CA actually gets a lot of power. Now, this fact that you can't write an RBAC policy that locks things down to the point of a certain type of secret is something that we're actively really looking at right now in the Kubernetes SIG-auth. And so this is a general problem that we have, is that there's going to be times where you want to have Kubernetes, secrets in Kubernetes, and you want to give access to a component. We don't have a lot of good patterns there. It ends up getting really fiddly. Ingress is another great example of that. And then service accounts is watch and list. Okay, that's should be fine. And then Istio Sidecar. So this is a role that we give. It's a cluster role that we probably give to every sidecar that says it can go ahead and get and watch and list the Istio resources. It can get, watch, list, and update extensions across the whole thing. So that's a pretty powerful thing to actually be able to update any third-party resources or ingresses. And then get, watch, and list of config maps, pods, and endpoints and services across the whole thing. And then we also have role binding that says that, okay, in any particular namespace, you can give the Istio pilot service account access to this cluster role. Similarly, for the Istio CA service account gets access to its cluster role. Similarly, for the ingress service account and the sidecar role binding. Okay. The sidecar role binding says the default service account in whatever namespace actually. Okay, so this is actually a little bit of bad policy here. You generally don't want to use the default service account and give it too many things to do. And it gives it the cluster role for Istio Sidecar that ends up actually being relatively, this update here is not a great thing. Okay, so that's something to look at later. There might be some good reasons for that, but I'm going a little bit depth first here in some of this stuff. So, okay, so we're going to go through and we're just going to apply this to my cluster. Okay, somebody says, does the cluster role mean my sidecar, which is deployed on my namespace, could gain permissions to edit C resources on another namespace? Yes, so anything that you're doing that's cluster role actually applies across the entire cluster, and it's not scoped to a specific namespace. Elric's asking, what is a sidecar or sidecar proxy? Okay, so Tim Hawken, and I'm gonna look it up real quick and drop the thing. Just did this really fun presentation. I think he said he did it like this morning or yesterday morning here. That explains sort of like the relationship between containers and pods. But a sidecar is another container that you put in a pod to make your main container, to give it some superpowers. So you can think about it as sort of a buddy process that actually gives your main process access to some stuff. And so when we talk about deploying a sidecar, what we're really talking about is running another process that does something special, that gets sort of hooked up and gives some extra capabilities in a sort of one-to-one way with the main workload. All right, there we go. Let's see, and here we go. Okay, so we're back to this. So we're going to go through and we're going to do a kube control apply. Yeah, Tim's deck, if you have a chance to go through it. Oh, I have to go to the Istio. Actually uses this analogy of like, protons and subatomic particles versus atoms versus molecules and all sorts of other stuff. So it's kind of a really cute thing that he did there. Okay, so this created a bunch of cluster roles and a bunch of role bindings. And these role bindings, you can see them here. What if I do OY? Does it actually show me? Okay, it shows the service account and has access to the cluster role here, but there's these things don't show up. These are specific to the default namespace. So the -n there says which namespace I'm going ahead and looking at. All right, let's keep moving. All right, so we go ahead and created those. That all seems to be working well. And then create my cluster admin binding, cluster admin, my name, this user. Okay, so I don't need to do this. So, okay, so what this is saying is that I want to actually give myself access to the cluster admin role. And the way that we're doing auth in these things is that we're actually using a certificate that essentially gives us cluster admin. I'm not sure exactly in the clusters who we authenticate as. I think it's like as like cluster admin. As we go through and start having more fancy ways of doing authentication in our quick start, which is something that we're looking at. This might be, say, a GitHub username or something like that you're actually talking about. So one of the interesting things about Kubernetes, and I should probably do an episode on RBAC and auth and authorization and authentication, is that the authentication and the authorization stuff is very pluggable. The interesting thing here is that if you can run this command, you already have that permission. I believe that the Kubernetes RBAC system does not let you expand scope, right? So this probably ends up being a little bit of a no-op, I'm guessing. Okay, and then this is saying whether, okay, this is dealing with two versions of our RBAC. Okay. So this was, I want to make sure that I'm doing this right. Okay, so we have the alpha and the beta stuff. Okay, yeah, so this is, I believe if you're running a 1.5 cluster, you only have the alpha RBAC and you don't have the beta stuff, and so that's what that's dealing with. Okay, enabling all metrics collection. Oh, this is fun. Okay, let's just go ahead and install a bunch of stuff. Okay, so this installed Prometheus and Grafana, and oh, we didn't get the service graph one. Did that get run? There we go, okay, and service graph. So this created a service and a config map and a deployment and a service. So let's go look at the sort of the Grafana service and see what that looks like. Or actually just do get service. Okay, so some of these things, this is interesting. So beware, I don't think they told you. These things are set up as type equals load balancer, which means that they're going to actually go out and create a public facing load balancer for this stuff. if you guys can copy down these numbers fast enough, there's a good chance that you might be able to log into this stuff for a while until I shut down this cluster. A couple of things to keep in mind. This stuff costs money. And so we're bringing up 3 ELBs here. That's not cheap, so you probably don't want to leave this stuff running for a long time. The second thing to keep in mind is that these things, at least on Amazon, can take up to a minute to actually become active. If you're running on GCP, instead what you'll see here are IP addresses because that's just the Google doesn't actually give you a CNAME. They give you an IP that ends up being globally available. And then the third thing is that when you tear down your cluster, you have to be careful of this stuff. With the Heptio Quick Start, when you bring up a cluster, CloudFormation knows about all the things that CloudFormation brought up. These things are actually created by Kubernetes itself. And so if I actually go through and tear down my Kubernetes cluster right now without tearing these things down, I might leave these things behind. And then I have 3 ELBs that are running that are essentially doing nothing. So there's a real caveat here about making sure that you clean up this stuff after the fact. Okay, so let's look at the Grafana one and see if that's up yet. It may take it a while. It says connecting. Is it? Yeah, I got an IP address for it. All right, well maybe, well, let's keep going through the tutorial. I'm skipping ahead here. And maybe we'll get back to that. Okay, verifying the, oh, it says, okay, I want to do this. Okay, so this is fascinating. So they go ahead and they do a type equals load balancer, which opens it to the outside world. Oh, but then they actually have you do a port forward. That's a little bit wacky. Okay, so Grafana is in port, no, that's Tim's face. We don't need to see Tim's face again. I like Tim, but okay. So we'll do that, port 3000. All right. Yes, look at that. Add users. Okay, so here's another thing. So Istio by default brings up a Grafana dashboard and exposes it to the world. You probably don't want to do that. And it seems unnecessary since the next thing they actually do is have you do this port forward thing here. So that we'll go ahead and do that. So, okay, so what this is doing in the background is actually going from my machine to the Kubernetes master, which also goes through an ELB. And then the Kubernetes master to a pod, and it's essentially very similar to opening an SSH tunnel. But the interesting thing is that kubectl port forward only knows how to actually go to a pod, but we really want to go to the Grafana service. And so what we actually do here is we say, well, get me the first, that's where these item 0, the first of the Grafana pods, right? So if I actually now go through and do k get pods, okay, but there's only one Grafana pod, so it actually gets me the only one. Yeah, so the proxy command, so Mateus says the proxy command is there for when you don't have load balanced services. Yeah, you can use port forward or proxy. Proxy only works with HTTP, whereas port forward works, at the sort of TCP level. So they work at different levels. The proxy, though, also enables you to do things like auth and stuff like that. But because it actually gets hosted on a different TCP path, it ends up having to actually do some really nasty things like rewrite the HTML as it comes back because it's essentially taking a site and rehosting it at a different level. So the proxy command is a little bit wacky. I prefer, when possible, to use port forward when trying to actually get directly to a pod. But the proxy does work against a service, whereas port forward only works against a pod. There's a lot there. Don't worry about it. Okay, verifying the service graph. So this is a new service. Okay, so this one, I'm going to go ahead and run this one too. And this one's running at 80 localhost, 88 there. Let's go ahead and try that. Oh, Mateus meant the port forward command. Okay. Did I say something else? Did I say proxy for? Okay, the port forward command. Okay, so we're at localhost not found, but we're actually getting a 404. So what is this supposed to be doing? Okay, so graph. Oh, I'm supposed to open it at .viz. Okay. All right, so another thing is that'd be nice if that thing actually had, so this is tiny example. All right, nothing to see here yet because we're not running anything. Okay, but I love how it says tiny example. Oh, okay. I missed an install step before doing the Grafana stuff. Let's see. Verifying the Grafana dashboard. I ran these three commands. I then went through and I did this. Oh, and then I can actually go to the Istio dashboard, what actually has all the dashboard that gets pre-built. Okay, so that's nice. So the Grafana dashboard that they set up already has a bunch of interesting sort of graphs and stuff configured. So they must do a little bit of work to do that. Actually, so let's go through, and I didn't look at these before we ran them, but if I look at Grafana here. Oh, so this is an Istio version of Grafana. They're not taking the stock thing, so they must already have some data pre-populated for the dashboards there. So I don't think I missed. If you think, Federico, if you think that I missed some stuff, let me know. I think we're still on track here, though. It says after running some services and installing book info, we'll see this. So this is the type of thing that we see all the time, and there's so many services in Kubernetes that actually bring up hey, this thing talks to this thing, talks to that thing, and that's one of the things that you actually get out of this also. Okay, and then we can actually enable Zipkin. Let's go ahead and do that too, because why not? Okay. So that created a service too. Okay, get. And that one is type equals load balancer also. So now we're up to 4 extra ELBs on this thing exposed to the world. So Zipkin, okay. So are folks familiar with Zipkin? This is one of those interesting things that we can do with something like Istio that's hard to do otherwise. Zipkin is a distributed tracing system. And what Zipkin does is it helps you, as you're running your program, actually save information of I started this and then I started that. And if you do that across a bunch of services in your service mesh, it can then actually go through and collect all those things and then give you an integrated display of sort of life of a request across your entire mesh. And it's really interesting if you get this done well. You can say, do a request and see everything that it actually hits, and then relate that down to maybe even the number of disk seeks or the number of sort of page faults that you actually hit on this stuff. So it's really interesting stuff. Okay, so I might have missed. Oh, I missed installing Istio's core components. This was the thing that Federico was talking about. So let's go ahead and do that. I skipped ahead. I'm not going to look too closely. Okay, so we installed the mixer and the pilot and ingress and egress. Okay, so we got that stuff up and running. And then we're going to install Istio auth. And this lets you do mutual TLS, which is a whole nother... Oh, wait. Oh, without enabling that. Okay, so I didn't read carefully. So let's go through and let's kube control delete. We're going to delete them all. Not kube control, kube cut off. What? Okay, what the heck did I do? How did kube control disappear? Did I accidentally delete something someplace? I have no idea what happened there. There's ghost in the machines going on here. Okay, so I missed this step. Apparently you can run it with or without auth. The auth one installs the CA also. Oh, kube control is the file. What? Am I an idiot? What did I do here? Oh, did I actually kube control delete -f apply? Oh, ha! No wonder. Install Kubernetes Istio auth. Not delete. There we go. Bingo. There we go. Haha. How did I screw that up? That's hilarious. Totally confused me. So I'm just going to tear this down because I ran both of them and I'm not sure of all the options. and create doesn't do an update. These things should probably be using apply, not create. We'll go, okay, so none of these things are running. Now I'm going to bring up the one with auth, because I think auth is one of the most interesting things that this does. And I'm just going to go through and copy this one. Okay, so we install the mixer, the pilot, the ingress, egress, and the service account. Oh no, and then CA. The CA is the certificate authority. Okay, so now we got all that up and running. We're back running. Keep an eye on the clock. Zipkin. Okay, cube, control, get service. And I have, okay, the ingress actually gets an ELB also. And we're sort of waiting on that. So that's pending. I may have hit the limit of the number of ELBs that I can have in this in this thing. So EC2, what are the default number of ELBs? Limits, I'm guessing, okay, load balancers per region is 5, security groups per load balancer. Okay, so maybe it'll still come along. Oh, there it is. Okay, just took it a while, because that's the one we actually need, I'm guessing. And this is listening on 80 and 443. Okay, so where are we at? Okay, so we go there. So here we can see external IP. Note that if your cluster is running in an environment that does not support external load balancing, the external IP will say pending. You will need access using the service node port or port forwarding instead. The interesting things here is that in this case, in this example here, the only thing that is type equals load balance is the ingress, but in mine, they all got it. So, well, the pilot and the mixer and egress didn't, but all the add-ons did. So that's something that's worth looking at. And then check the pods. And we have a bunch of pods running. Oh, we got an error on ingress and egress. What's going on here? Cube control disk. Failed. It's in back off. Was scheduled, started, failed sync. Error syncing pod, failed to start container for proxy. So what did I do wrong? Okay, the TPR Istio config is not ready. User assist. Okay, so what's happening is that this thing is trying to reach a third-party resource. It's probably waiting for one of the control plane things to actually go ahead and create that, and then it goes into a crash loop waiting for that thing to actually show up. Okay, so here we say, from the logs of mine, it looks like it doesn't have a working service account. User system service account, Istio pilot service account cannot list Istio configs, Istio IO at the cluster scope. My guess is that it's because those haven't been created yet. Okay, oh, now we're seeing that also. So it's still, do it, this is in cube system. Okay, do we skip a step? Do we actually go through? We did that, did that. It could be, is it an RBAC thing? All right, let's see if we can figure out what's going on. Okay, so let's think here. So this stuff is all working. I don't know enough about Istio to be able to really debug this, but let's go through and look at, let's figure out what's happening with the pilot, because that's something important. The container name must be specified for pod Istio pilot. Choose one of, okay. This is probably API server is the one. Oh, look at this. Waiting. Failed to register third-party resources. User system account Istio pilot server cannot get third-party resources extensions at the cluster scope. Get third-party Istio. Okay, find out who has permissions to create the TPR and look at the pod running by that SA. Yeah. So our third-party resources aren't getting created. Okay, get logs the mixer here. All right, this thing is proto ww load new config store starting gRPC service. So this is a registering. This looks like it's registering some metrics for Prometheus. No coders for interface, no encoder for params. Descriptor, this is like all meta stuff. So that thing's not doing it. Who actually creates the... All right, so this is how you know it's live, right? Okay, so we have Istio auth with cluster CA. Now, is this thing? Okay, so the RBAC stuff actually should let this all happen. Who's supposed to create these things? So typically, it's an admin-y type of thing to create them because you only have to do it once, and then all the auth stuff is actually written in terms of that. But it looks like this thing's trying to create and manage them itself. So it's probably the Istio pilot. The mixer is probably the one that's doing it because everything else is crashed waiting for this stuff pretty much. Cube control, get pod, cube control, get deployment, mixer. All right, so what is going on here? So I'm looking at the definition of this thing. Labels, rolling update, blah, 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 template, sidecar, ignore. So you don't Istio. Configure store URL, config root, log the standard error, v3, Istio, pull policy, ports, message path, restart schedule, security context. Where is the service account this thing's supposed to be using? Okay, an install page. If you get an error, well, let's go look to see. Maybe I didn't read the instructions. If you get an error. No, we didn't get that error. I don't think that's... You need to add the following. That's not the error that we got. Okay. Because we're actually down like here. And it's talking about pending of the services and then looking at the pods. And so the fundamental problem here is that the pods themselves... Okay, so Kubernetes is fundamentally an extensible system, and so it has a bunch of built-in types, objects, and thingies that you can go ahead and manipulate. But then there's this thing called third-party resources where you can say, hey, I want to create new types of things that are application-specific, but I want Kubernetes to essentially be my object store for storing these things. And this is what third-party resources are. It turns out that over the next couple of releases, 1.7 and 1.8, we're deprecating third-party releases for this thing called custom resource definition, CRDs, TPRs to CRDs. three-letter acronyms are not great. But the idea is basically the same. But there's two ways that you can go ahead and do that. Is that you can have as part of your install, you can create essentially the definition of these third-party resources, or you can have the application itself sort of as it installs itself, go ahead and create these third-party resources. I prefer the former, but it looks like Istio is doing the latter. It says, okay, the pod shows service account name here. Where do we see that? Do I see that selector, templates? It's in the pod template. It would be spec, containers. I see security context. I don't see service account. It probably ends up being, let's see if we go and look at the pod. And we're looking at the mixer. Cube control, get, pod. This thing here, so this is the full pod thing. As part of this, we're going to get the service account is default. And my guess is that we don't want to actually, the pod itself, is that we don't want this thing to actually use the default service account. Cube control get. We probably want to use the pilot service. Well, this is the mixer. So what is the mixer supposed to be doing? We have the pilot and the mixer. And honestly, I don't have a really great feeling for which one of these is actually going to create the TPR definition. Maybe I missed a step up here. So we do the RBAC stuff, and then we go ahead. It would probably be part of this. Let's see. Istio.yaml. And then we have the mixer. There's a thread in Istio RBAC issues 161 and K164 that references a PR. Let's look at the PR. Okay, so yeah, I'm not the first one to hit this, but I am also not the first one to Google when you hit a problem. So we all have. Probably should have done it already. Okay. What does this thing say? Here's the issue and the pull request. And if it's pointing Istio namespace other than default, then change the cluster role by namespace target appropriately. No, I didn't do that. We need to be able to list and get namespaces. That's not it. Wow, so this thing has to be able to update secrets. I don't know if this is it. So, okay, so you said, Ken says, on mine, I edited the Istio mixer deployment, added service account, Istio pilot service account. I think that's probably it. Istio ingress service account. Actually, let me look at, I'm not sure that this is the issue that we're hitting, but I'm about to whack it with the ugly stick and get it going again. Istio mixer. It's the mixer that okay, so RBAC, that's installing the RBAC stuff. And then Istio auth, okay. The mixer doesn't actually use. Okay, I think the problem is that the mixer needs to do stuff and they actually didn't give the mixer an RBAC role. So that's my guess is the problem here. All right, so let's go ahead and, so Ken, you said you gave the mixer the pilot essay. Okay, so we're going to go through, edit it live, K, edit, deployment, Istio mixer. And let's see if I can figure out the syntax. And then I'm going to go through and can you all see this? And I'm going to go through and I'm going to do service account It's Istio pilot service account. All right, what's the worst that can happen? Okay, so that goes ahead and does that. Oh, look at that. Now they're up and running. Woohoo. Yeah, so if we go through, so now the mixer is actually doing its thing and creating the, why? Okay, so, oh, it's recreating. Oh, these things eventually got running. I wonder, okay, this is really odd. How did they get running? Okay, so Istio 327, so JJ's saying that. Okay, oh, 327, okay. 27. Istio Manager cannot list or create TPRs when RBAC is enabled. So what did he do? He went through, the issue appears to be that the manager servers are doing get at the cluster scope, and we have a role binding which is namespaced. Either you change the code to do a scoped get on namespace or change the following to a cluster role binding, add the namespace as a subject. Okay. Same issues. So this is still open. Create cluster role binding cluster. That's a different issue. Okay, cluster role binding for manager services are doing get at the cluster scope, and we have a role binding which is namespaced. Either you change the code to do a scoped get on namespace, which we're not going to change the code, or change the following to a cluster role binding. So this is the Istio manager admin role binding. Do we have that? Istio manager service account? So we don't have the Istio manager service account. So I don't even know, this must be, my guess is that this stuff is all, the RBAC stuff is a little bleeding edge. Because I bet if we look at the code and we look at the install Kubernetes, Istio RBAC. Oh, a manager got renamed to pilot. Okay, that's not confusing at all. Yeah, JJ's way ahead of me here. All right, so we're running out of time here. But okay, so I think we got pods. No, it's still in crash loop back off. Darn it! What did I do? What did I do? So I had to. Let's go through and let's try that thing. RBAC beta. So this is a cluster role binding. Oh, I got it. Okay, so pilot service account. This is a role binding, not a cluster role binding, which means that the pilot only gets to see stuff, but it may actually be looking across. So this is expanding scope quite a bit. So then we'll go ahead and cube create. What is it? It ends up being cube control create -f istio RBAC beta. I get a bunch of errors since I'm actually redoing stuff, but it actually should have created get cluster role bindings. And we end up with admin, cluster admin. Wait, where are the cluster? All right, so JJ is saying I should keep going. I do have some meetings coming, but let's give it a try. Okay, oh, this one, so cluster role bindings is invalid, namespace required. Wait, why does the cluster role binding? So name, subject, service account, role ref for the cluster role. Oh, I need a namespace for the service account because it's no longer in play. Let's try that. All right, now we have the Istio pilot admin role binding, which means that it gets access across. It gets access across all namespaces. Oh, maybe I was wrong when I was describing the cluster roles before. That's just the scope. That's the cluster role binding that actually gives you access across everything. Okay. All right, so we're now in a crash loop back off here for this thing, so maybe okay, resource already exists, checking for TPR resources. Some stuff's happening. I think it might be running. So the mixer, I was probably wrong. The mixer probably doesn't need that scope. We won't fix that. Okay, so that looks like that was the issue that I hit here. Is issue, where was this? 327. Istio Manager, the pilot, cannot list or create Kubernetes TPRs when RBAC is enabled. And I think some of this is that third-party resources are, all right, I am putting a call out there. I am happy to help the Istio team get their RBAC house in order. Let's get this stuff figured out. Okay, so we are back to the races. Let's go ahead. We have all this, boom, boom, boom. We're now there. Deploy your application. Okay, so this is fascinating. So there's this thing called Istio control kube inject. And what that does is that takes a YAML for a Kubernetes pod definition and it Istiofies it. And what that means is that it goes through and it injects into that thing the Istio sidecar. So there is this problem with sidecars where you want to take your application as you've described it, and then you want to add that buddy thing to it. And a lot of times adding that buddy thing to it ends up being really fiddly. You have to sort of like add some stuff here, and wire stuff up. And so there's a couple approaches that folks take to it. One of them is shipping a tool like this, which essentially says, I want to take the file and I want to go ahead and munge it before I actually apply it. And so Istio controls that munging. Another thing is this thing that we're working on here at Heptio called KSonnet, which lets you actually ship this as a library and actually integrate it in a place where you can see it. So it's not sort of a pipeline of injection or modification. We're doing something similar we just wrote a blog post, I think that came out yesterday, about doing this with the Honeycomb agent, which runs as a sidecar also. It's on my list to actually look to see if we can actually write a KSonnet mix-in for applying Istio. So that's one of the things that I want to have happen. All right, so we have this book info example. Let's get that up and running. Okay, let's see. We have a Python thing talking to Java, have some Ruby and some Node in there. Do not try this at home. No, seriously, do not try that at home. But it does show off the power of making this stuff be a sidecar. All right, so here, okay, so we have deployment, reviews, details, product page, ratings. That stuff is all up and running. We have a new ingress called gateway here. I can do kube control get services. Wide because these things are really big. I can hit the ingress thing here. Let's see, OY ingress. Okay, kube control get ingress. Okay, so it's saying that the ingress called gateway for anything forwarded onto to port 80. Okay, if your Kubernetes cluster is running in an environment that supports external load balance and the Istio, okay, we have to do node port stuff. I can go ahead and do that. Confirm that doing a curl application. Okay, so export gateway URL equals this. Now this is not an URL, that's a host name, but they name the thing URL. Okay, so that did not work. See, this page isn't working. Okay, so what did I skipped a bunch of steps. Let's go back a little bit. So I went ahead and applied that. I go through, if I do, I have a bunch of stuff running, including applications and Istio stuff. Now, I think in the fullness of time, Istio will be a cluster level thing that gets installed, and so you won't see any of the Istio stuff going on here once things are totally up and running. Determine the gateway ingress URL. If your Kubernetes cluster is running in an environment that supports external load balancers, the Istio ingress service was able to attain an external IP. It's actually not an external IP. It's the ingress will blah, blah, blah. Sometimes when the service is unable to attain the ingress address may display a list of node port addresses. We're not there. Well, actually, we can use node port maybe. Because there's the node ports that got assigned. If your deployment environment does not support it, then we can go ahead and do this to actually go ahead and get stuff. So we're not going to do that. Confirm the application is actually up and running. So something wacky is going on here. All right, so this is this thing is actually getting there. Okay. Empty reply from server. What is going on now? What is going on now? Istio control get. Oh, I don't have any of those. Why don't I have any of those? Did I, like, something not get installed? Let's try and apply this again and see what happens. Ingress gateway got configured. If I look at the pods, cube control pod, and let's look at one of these. This thing has, so we can see here, okay, there's like this init container that's going through and setting some stuff up. So there's a bunch of Istio stuff that actually gets set in here. There's another thing, the enable core dump container that gets set. And then here's the main application container called ratings. And then there's another thing here called proxy. So that's the Envoy proxy that's doing stuff. So, okay, so that's getting injected. Okay, try from inside the app pod. Yeah, we can go ahead and do that, but that's no fun. Let's go through and we'll at least do, we'll at least actually SSH into the master of the thing. Let me find the right magic incantation for that. Okay. So now I'm in the master here, and if I go through and I do export cube config equals k get pods. Oh, we have a crash loop back off there. Okay, so ingress is not running for some reason. What the get? So we weren't as up as we thought we were when we installed this stuff. And this thing is, TPR is not ready. So we still have this third-party resource issue. Okay, let me exit back out of this. Cube control get third-party Okay, so we do have the istio config istio.io, kube control get. So this is not actually getting created. I think, somebody was saying let's tear it down and try again. Kube control get pods. Okay, so let's go back here and we're gonna go through, and here we have a cleanup. I'm gonna run that. So RBAC is interesting in Kubernetes. There's a little bit of a chicken and egg thing going on here. There's a lot of folks running without RBAC. And when you do, everything's really easy. But we really think, to build a secure cluster and for the future of Kubernetes, RBAC needs to be a thing. We need to get it done. But because a lot of folks aren't running with it by default, because stuff like this happens, that means that they're not actually hitting these issues. And so we're seeing this happen quite a bit, and that's unfortunate. Okay, uninstalling. We're going to go through and we're going to delete all this. We're going to delete the RBAC rules. I think it's probably going to leave one thing around, but that's probably fine. Delete all the add-ons. Yeah, so you can see it's asymmetric. Here we're actually going ahead and deleting the Istio configs and the third-party resource. That should be an admin thing about like installing Istio. It probably shouldn't be doing it itself, because then it's asymmetric and cleaning it up. Okay, so now we're going to go through and we're going to do this again. We're going to install the RBAC stuff. Go ahead, and we did a cluster role binding for the pilot admin role binding. Actually, you know what? Let's see what happens there. Okay. We're going to install Istio with Istio auth. Go ahead and do that, and then we're going to go through and install the add-ons. Okay, some stuff is running. Let's look at the pilot. So one of the interesting things that I think folks are going to hit as we do more and more Istio stuff is that they're going to go from running pods with a single container to running pods with multiple containers. Because like right now, if you do kube control logs and you specify a pod, if that pod only has one container, it'll actually grab that one. But if you actually go through and now it has two of them, you have to do a like API server. So like I predict that what we're going to end up doing is adding an annotation on a pod that says default log container. That'll actually point to the container name, and then we'll have kube control logs do that and probably surface a warning message saying, hey, there's multiple logs. I'm going to actually go through and do that. Okay, so we go through and we did this. Let's see. Oh, okay, so we're getting error with ingress. So waiting, 2 errors occurred. Failed to register. Cannot get third-party resource extensions at cluster scope. Okay, so the problem here is Kubernetes RBAC cluster scope. So I believe that the way that roles work is that you talk about these things, the namespace is implied. Cluster role can be used with namespaced resources across all namespaces. Okay, cluster role can be used to grant the same permission as role, but because they're cluster scopes, they can be used to grant access. Okay, so I think we have to make all of these things. Yeah, you're right, Ken. I think I needed to change all of these things to cluster role bindings. Okay, this is making me nervous, but we need to. This is in some ways sort of like giving this stuff a lot of access to a lot of stuff. Because some of the permissions can be we need to be cluster role bindings, and some of them only are namespace specific. But oh, and then I needed to darn it. So this is parameterized based on. Okay. Yep. Get pods. Terminating, creating, it's running. All right, I think we're there. All right, let's assume that we are. Oh, and look, my last pass appears to be expired because security. That is not the thing that we're looking at. We're looking at this. We're going to go forward to this page. This is the one for our example. We're going to do book info. All right, so it's running the init containers, pod initializing. I think we actually might have the thing. And you guys are like, I'm reading this, Steve was like, don't forget the namespace from before. The delay here is just killing me. But we're pod initializing here, some stuff is coming up. Instead of hitting up arrow, we'll just slam it, there we go. So the show must be over because I'm out of beer, but we're still getting there. Pod initializing. So now, okay, so I'm going to do get services. We have all of our services here. I'm going to hit ingress up. Is this actually going to be, I'm not there yet. Let's wait for the pods to actually show. Reviews. Is this it? All right, what's going on now? Book info. Oh, product page, okay. What is this with like people not creating a home page for these things? Look at that! It works! Look at this fine Bootstrap inspired web page that we have here. Very nice. Okay. All right, so RBAC was the big issue here, but since we're here, let's play around with like some of the other stuff that we have, some of the other services. So we said that we had, so now that we have something running, yeah, we need the party parrot here. Woo, I'm gonna hit the gong. All right, so we're going to show the Grafana dashboard. Is this thing still? Oh, this thing. What happened is these things are still running, but I'm going to run them again because it turns out that these are based on a pod name, and when I restarted all the pods, these things kind of crapped out. So this is one of the sort of perils. Of the port forward stuff. There we go. Okay, request volume. Is it going to show up on the Grafana? Oh, look at that. I hit reload a bunch of times and we actually see this stuff. Service mesh, success rates, you can see this stuff. and then we can actually look based on, okay, so coming from the product page, going to the reviews, I want to break it down. I can do, services review. So, okay, so we can actually go through and start to narrow this down. So that's pretty cool as we actually sort of look at. So it's not quite the graph view where you can start looking at stuff directly. That, I think, comes from, if we go back, maybe. Oh, every time I do this, it actually, installing Istio. The graph service, I want to look at this thing. So this is doing a .viz thing. Okay, so, and every time, you got a lot of dot. Every time I reload it, it actually rebalances it to a different layout. So this is showing that work's coming in from unknown, which means sort of outside the cluster, going to the product page. It's calling to the reviews, but there's 3 different paths because this is the review service, but apparently it's using an edge per version, so you can actually figure out from different versions. That goes to details and then goes ahead to that. Yeah, okay, so I think I am over time. I'm going to hit the gong, though. So, okay, so here's the thing. One of our folks who does a bunch of our services stuff, he has 3 sons. So it is a very male household there. And one of them started doing percussion and it had a little snare drum. And they're like, okay, we got to start doing the drum kit. And so he bought his son a 40-inch gong. This thing's absolutely enormous. And with the idea that, you got to start building out your kit somehow. It was too big for the house, so they brought it in here. And so now every time we get a new customer here at Heptio, this will not scale, we get to hit the gong. I'm not going to hit it that hard because honestly I'm going to go deaf, but let's go ahead and give this a try. And for the folks watching out in the office out there or in our neighbors here in Seattle, I apologize, but here we go. Oh yeah. It goes on for a long time. So with that, and maybe we can make this a tradition where I hit the gong at the end of every show. I don't know. So with that, I'm going to go ahead and sign off. We can take some time, maybe next time, to actually dig into some more of the details and actually play with this. I want to try it with some of my own applications and see how things work. And thank you so much, and stay tuned. Please hit the subscribe button. I think we're almost to 100, which means that I think once it's 130 days, we actually get our own URL at YouTube, so that's kind of fun. And spread the word, and I'll keep doing these. Thank you so much.